Hi everyone, and welcome to today's webinar on performance testing. So in today's webinar, we'll have some introductions, introduce myself and my colleague here who will be presenting the webinar. And we'll go over some of the key topics around performance testing. So why we do performance testing, the different types of performance testing that we do here at Portaltech Reply. When should you do performance testing, benchmarking, and then we'll look at the more technical areas around tooling, profiling, and common issues and challenges that we face when doing performance testing. And then we'll have a Q&A at the end. So some quick introductions. My name's Oktay Zorlu. I'm a solution architect here at Portaltech Reply. I've been here for over 10 years, working on enterprise solutions ranging from retail to fashion, pharmaceutical, airlines, and many B2B projects. We are working primarily on SAP Commerce, but we are also looking at working with other e-commerce platforms now as well. And I'll pass over to Hafthar so he can introduce himself.
Hello, everyone. So my name is Hafthar Kottikkal. I've been working with Portaltech Reply for the last 7 years. I'm a tech lead. As Oktay said, recently we've been working on optimizing the performance of enterprise solutions. I've also worked on retail, travel industries.
Great, thanks, Hafthar. So let's go into the webinar. So first of all, why is performance testing important? And it might seem like a silly question, we all know the importance of performance testing. For us here at Portaltech, it's the primary and the first non-functional requirement on the sheet. However, we find that it's usually the neglected child in many software development projects, even though it always comes back to bite with a vengeance. It's traditionally forgotten until we get to the last stages of a project, and then it's put together in a rush. We know performance testing is a critical part of the software development and application lifecycle, designed to evaluate the speed, responsiveness, and stability of a software system under various conditions. The primary reason to conduct performance testing is to ensure the software or system meets its performance objectives and to identify and address performance issues before it's too late, i.e. before it goes to production and impacts your users. We also know that performance testing of a site is one of the key reasons why users will abandon their user journey, resulting in lost sales. So me personally, if a site is not performing very well, it's one of the main reasons why I would abandon my user journey, because as you can imagine, it's a very annoying experience when a site is not performing well. So performance testing can also be a cost-saving exercise, which might be surprising for many of you, because when you do performance testing, you actually find and optimize the resource utilization within your infrastructure, meaning that you could potentially use less resources, which will mean you'll have you could have cost savings. So when we're doing performance testing, we always make sure that the system can reliably handle the expected levels of traffic, but not just the expected levels of traffic, the peak traffic, which we refer to, but also traffic above these levels. And what we typically do is test at around 20 to 30% above peak traffic levels. From my experience with projects in my career, which go live, typically have very few functional issues, because we have QA, we have automation, we have UAT, which all concentrate mainly on the functional requirements. Can a site provide a feature? And those are the areas which are tested using automation testing QA, like I said. One of the main reasons why a site might even have a rollback is because the site is not performing well. And this, like I said, is because not enough effort and emphasis has been put on performance testing. So any new application should have performance testing planned and scheduled as part of the project implementation from the beginning of the project. As soon as there's a functional journey or an API that can be tested, performance testing should be kind of integrated into that implementation plan. But if we look at projects which are already live, and we've had clients come to us which are live and they're having performance issues, there are certain times within a project where it makes sense to have a performance test. And here are a few key reasons why you would have a performance test. So environment sizing and identifying scaling bottlenecks for growth projections. So if your expected levels of traffic are going to increase by 50%, projected increase of 50% over the next 6 months, you want to make sure that your environment is sized correctly and can handle that additional traffic. Preparing for significant events such as Black Friday, always you will have some idea of what levels of traffic you're going to expect over these periods, and making sure that your system can handle those levels of traffic, but not just those levels, but higher, 20-30% higher, just in case. It's always a good idea. Quarterly cadence as a BAU activity. So if you have a very active system where new development is constantly being introduced, it's a good idea to have some performance testing periodically throughout the year to make sure that no new development has actually caused any performance degradation. Core platform upgrades. Of course, if you're doing a core platform update, you're changing a lot of code in your system, and again, it's a good time to do performance testing. A new set of integrations to third parties, especially if these are integrations which are called upon during runtime. So throughout the user journey, if you've introduced new third-party APIs which are making calls to, you want to make sure that those API requests are very quick in responding, because it could impact the user journey. Introduction of new functional capabilities, I think we discussed that. Third-party upgrades or library upgrades, similar to a core platform update. If you're introducing new third-party libraries, you want to make sure that they don't have a negative impact. And any changes around the database, because the database can be a bottleneck for the whole system, especially if you have just one single database. So any changes around the database should also be tested. So let's move on to the types of performance testing we cover here at Portaltech. Now, we've just highlighted 6 most common types of performance testing. I think 4 of them are quite common and 2 are more specialized. I just wanted to add 2 specialized tests in there as well. So let's just go through these quickly. Load testing is the most common. It assesses how your system performs under expected load or peak load. It helps determine the system can handle the anticipated number of users and transactions or data volumes without degrading the performance of the system. So the goal here is to identify performance bottlenecks and ensure the system meets its performance objectives. Load testing is, like I said, the most common test we would do. And it typically will find the main issues on bottlenecks within your system. However, there are some more specialized tests, such as spike testing. So spike or stress testing evaluates a system's behavior under extreme conditions, such as a sudden spike in your traffic, a rapid increase in data volumes, or hardware failures. The goal here is to understand how the system behaves when pushed beyond its limits and to identify failure points and vulnerabilities. But also, this will mimic a promotional behavior. So if you have a flash sale of 50% on your site and you send out 1 million emails to all your subscribers, you're going to expect a very high spike in traffic, and this could be above your expected levels of traffic, and you want to make sure that your system can handle these spikes in traffic. So this is a very useful test for that. Another useful test is soak and or endurance testing, which involves subjecting the system to sustained load for an extended period to identify performance degradation or resource leaks, things like a memory leak, for example. So it helps ensure the system remains stable and responsive in the long run. So I've mentioned memory leaks. So this is a really good test to see if there's any memory leaks within your system, because issues like memory leaks are not always visible when you do things like spike testing or load testing, because these issues tend to come to light over a sustained load over a long period of time. So having these tests run for sometimes over a day will identify issues in your system, which typically won't come to light using your traditional load testing or spike testing. So scalability testing assesses the system's ability to scale horizontally, so adding more servers and nodes into your system, or vertically, so increasing the resources of your servers. To accommodate increased load, it helps determine how well your system can grow to meet future demands. So I would say scalability testing is more testing of the infrastructure to make sure they can scale as intended. So if you have, for instance, if you have a system where you have, say, 10 servers, but it can auto scale up to 50, you want to make sure that your system will scale without impacting performance up to the 50 nodes when the traffic increases on your website. So this is a very useful test for testing the scalability of your infrastructure. The final two types of test, volume testing and concurrency testing, more specialized tests, like I said. Volume testing evaluates the system's performance with large volumes of data. It assesses how the system handles increased data volumes, such as database size, file storage, or message queues, without degrading the performance of your site. So this test is more around testing your system with larger quantities of data. Concurrency testing examines the system's behavior when multiple users or transactions access the system simultaneously. It assesses how the system manages concurrent requests, locks, and resources to prevent congestion, deadlocks, or race conditions. So this test is very useful, especially in things like the finance sector, where you have a large volume of transactions which are getting executed at the same time, and you want to make sure that there's no concurrency issues. Like I said, there's no deadlocks in the database, and all the users are getting a response in a timely manner. So let's move on to benchmarking. So benchmarking for performance is critical. It establishes a baseline for performance. So you would typically do a performance test. It supports the SLA compliance. So you would typically have some SLAs from your client to say certain APIs or certain web pages need to respond in a certain amount of time. Once those SLAs have been agreed and you do run a performance test and you're within the SLAs, then you can use that performance test as a baseline for any future test. So you're just drawing a line in the sand, if you like, and saying, this is an acceptable performance test in terms of response times, and we will compare any future tests to this baseline. So what this does is it provides a comparative analysis over time. So you'll build up this report and you can see how response times will fluctuate since you've taken a baseline. Like we said, it's setting the baseline for future tests, identifying issues introduced by new development. So once we have a baseline, we run a test, we compare it to the baseline. And if we see that an API is taking twice as much time as it was compared to the baseline, we can determine that something's been introduced here, be it data, be it new development, be it a network issue, an infrastructure issue. Something has happened where this API is no longer performing as well as it was. We can also use it to validate performance improvements if you've made any changes in that area. We've talked about SLAs, and the baseline should typically be done on a production-like environment. When we say production-like environment, we're talking about a pre-prod environment where data, infrastructure resources, third-party integrations are in line with what you would expect from production. Now, this is for a greenfield project which hasn't gone live. You can actually use the production environment for this in this instance, but for any project which is already live, you can't use production for your performance tests. But you would have to have an environment which is very similar to production. Now, there are instances where low specification environments can be used, but if you are using a low specification environment, say a staging environment, you would want to maintain that spec for any future tests so that you will have, so you can compare, you can have a comparative analysis. If the size of the environment changes, then you can't really compare to the baseline. Great. So I'm going to hand over now to Hafthar, and he's going to go into tooling and profiling.
Yeah, thanks, Oktay. So yeah, now that we've covered the importance of performance testing, let's talk about a primary tool that we use in Portaltech, which is JMeter. So JMeter is a widely used Java-based open source tool that help us simulate load on web servers, APIs, or databases. JMeter helps us to understand how our application will handle multiple users interacting with it. Let's see how a typical life cycle of a performance test will look like. This diagram illustrates an end-to-end approach from defining the user journeys to reporting, fixing the issues. Usually we start by defining the user journeys. This involves outlining the most critical path a user take through the site. This could be product search, checkouts, or any other significant action. So once we define the user journeys, we run a load test or any type of performance test on a baseline version of our site or the infrastructure. This will help establish the system's performance under the normal conditions. So once the load test is done, we compile the results into a report. This report will highlight any areas where the site is underperforming, and it will give insights into the load capacity of our system. So with this data, with this test data, what we do is we set performance targets. These targets should be aiming to reduce the latency enhance scalability and improve the user experience. So once we set the targets, we perform the load testing again. And if there are any bottlenecks identified, we investigate these issues in depth. These bottlenecks could be coming in from processing power or database queries or application logic. So once we understand these bottlenecks, the next step is to implement the corrective actions so that these issues can be resolved. This could be various things like optimizing the code or improving the database indexing or even adding more resources to the environment. So this cycle of fixing the issues, running the tests will continue until we meet the set performance targets. Now let's take a step back and see how we identify these issues. So once we run the testing, how are we going to identify these issues? So once we have this test data, we do profiling. So profiling will give us a deeper insight into the specific areas that needs improvements. Profiling is mainly about understanding how each part of our application behaves under heavy load. This could be memory usage, CPU, or database performance. But how do we do the profiling? So this is where the APM or application performance monitoring tools comes in place. So these type of tools provide detailed insights into the application health, which will help us monitor everything from response times to the server errors. One such tool that we use in Portaltech is Dynatrace. It gives us an end-to-end visibility into our system. It will monitor every transactions across the application stack. It will even show us the performance issues down to the code level. This tool helps testers and developers for tracking down the issues, the root cause of the issues. This could be memory leaks or any code inefficiencies. It can also help us to optimize the user experience when the system is having a heavy load. These are some of the widgets we took from the Dynatrace. These are some really useful widgets which can help us identify if our system is under threshold and if we met the targets that we specified. So for example, this one shows how the response times and the throughputs were during the performance test. And we can also see the CPU and memory. And similarly, we have the DTU graph as well. So these are just a few of the widgets available, which we can use to monitor our system. Let's look at some of the common issues that could impact the performance of a system. So as the system grows, the most common problem we see is large database tables. The next one is the memory intensive DTO conversions. The DTO or the data transfer objects are useful in transferring the data between different layers of our application. But if they are not handled properly, this could be very memory intensive. The next thing we see is a big or monolithic JS files. So most of the sites, if you look, the JS files are like really big. So this would mean that the initial load of the website will be higher and the client will need longer to render these files. And same goes with the bulky API payloads. So we see APIs with really high request or response payloads. There might be APIs where which will have lots of redundant data that the front end might not even use. This will use a very high bandwidth, which will cause some performance issues for the user. Last but not least is the missing database index. So if the database is not indexed properly, then when we do a query, it needs to do a full scan of the DB to get the results, which will be time intensive. So to summarize what we just said, all those issues will result in high memory consumption, high latency, high initial load time, and high bandwidth usage. These are just some of the impacts, but there'll be more. So some of the suggestions or the actions that we took are using archiving strategies, which will get rid of old or unused data. Similarly, like we can implement like automated retention jobs, which will purge or delete old redundant data. Maintaining the database index regularly. So we need to monitor for example, like we can if there are queries that are high that are using the resources more, we need to add index for that query and monitor it. But we need to make sure that we don't do indexing, we don't overdo the indexing, because that will also cause DB issues. We could cache frequently used DTOs, so we can avoid the memory intensive data conversion. And for the big files, we can do code splitting. So we split the files into chunks, and then we could use the lazy loading mechanism to load the files needed to load a specific page or only a specific scenario. Finally, let's look at one of the challenges that we faced while testing a single page application. As we all know, in traditional websites, when we click, the page reloads, which makes the performance testing more straightforward because it allows us to measure the full page load times and the server response times. But with the single page applications, only part of the pages are dynamically updated, and most of the times the pages won't reload. This means we need to change how we measure the performance. So instead of focusing on the full page load times, we focus on API response times and the client-side rendering performance. What this will do is this adds complexity because we have to account for both the servers and the browser's performance. This would add more steps while doing the performance testing. With this, we conclude our session. Thanks for listening.
Great, thanks for that, Hafthar. Very interesting. So I'd like to thank you all for joining the session today and open the floor up to any questions.
So one question came from the office, and that question's for you, Oktay. How would you integrate performance testing into your implementation plan for a greenfield project?
Thanks, Loki. Yeah, that's a good question. I think for a greenfield project, taking performance into account right from the beginning of the implementation phase is critical. So as soon as sprint 1 is complete, sprint 0 is completed, or sprint 1 is completed, and as soon as you have an API, a set of APIs, or a user journey that can be tested, my recommendation would be that performance test starts then. This will give you a comparative history of how each performance test is working from sprint to sprint. So typically we would start at the beginning of the implementation phase, whereby at the end of discovery, at the beginning of implementation, the performance team will know which journeys to test, which APIs to test, because they should have documentation for those areas. And they would start writing the scripts to test these areas. And as soon as a few APIs or a journey becomes available on an environment, then they can start doing performance testing and taking a baseline, like we said, of certain APIs, so that as the sprints progress, they will have a comparative and set of data that they can use to analyze any degradation in certain areas of the site. So it's really key to start very early on.
Great. Thanks for that. That was a very detailed answer, and I'm sure the colleague who asked it will be grateful. And for anyone else, both in office or online, if you have any questions, now's the time. Of course, you can directly reach out to the speakers via internal platforms like Tamtami, or if you're external, LinkedIn. But yeah, now's the time to ask some questions. And whilst I wait for any to come in, I do also want to add, this recording will be live on YouTube after as well. But yeah, so we have some questions coming in. So the first question from Gabby: can performance tests be isolated to a specific component of the solution landscape, e.g. just the DB?
Yeah, I can take this one. Yes, it can be to specific components, but I would say because the database is kind of the funnel of your application, right? So your system will have various storefronts, it will be composable, it will have many channels of communication. All those channels of communication will funnel down into the database. So trying to test a database in an isolated way is probably not possible, probably because it touches every area of the site. If you want to concentrate your performance test on a specific area or a specific channel, that's possible. But to try to isolate the database by itself probably is not the most pragmatic way of approaching the test.
Perfect. Okay, and the next one's from Igor. You mentioned that it's good to start performance testing as soon as an API are available during development. Is it feasible to do, or is it better to wait with performance testing when the code is finished and no further changes will be required?
Yeah, so it depends on your definition of complete, right? So if an API is complete, i.e. that means it's completed from a development perspective, it's completed from a UAT perspective, then it can be tested, performance tested at that stage, because it's gone through the various stages of acceptance. So this is what we mean by starting early. Start early, but once a story or an API or a journey has been accepted, so that it's gone through the correct processes and acceptances, so that it's ready to be tested. Of course, you don't get a complete view of your application when you're just testing a few elements of it. But I think what it does is it allows you to build your performance scripts up gradually, rather than leaving it to kind of the last few sprints, where then you have a huge task in scripting all the features that have been implemented. Starting early on in the implementation phase also allows you to build up your performance tests gradually. Also be aware of all the features that are coming in after every sprint. So I think there's a number of advantages of starting early. And like I said, it also gives you a comparative analysis or statistics on how APIs have been working since the early stages of the project.
Perfect. So I guess we still have some spare time. We can allocate some time to let some more questions come in. And another point I'd like to make is if anyone would have any feedback for us, to please share that promptly after the session. It'd be greatly appreciated so we can improve going forward with our sessions. But yeah, we'll give it a few more minutes if that's okay with you guys, and just see if any more questions come in. But thank you both for your time as well. Great presentation. And yeah, the VOD will be on YouTube once again. So if you want to share it with any of your colleagues or rewatch to kind of digest the information at a different pace, that will be an option available soon too.